All right. Are there any questions on the homework? No, we're moving on. We're good on sum and product from yesterday. And find the equations. We understand what we're doing there, that we might find one possible equation, and we're stressing the fact that an equation means it equals something versus an expression, right? So if you just write x squared minus 6x plus 3, that's going to be an issue, right? Because that's not an equation. We're good on that? Okay, so moving on? Yep. That was easy. All right, so today should be, if you're good on everything from yesterday, today should be pretty easy, actually. So we're going to extend sum and product just a tiny bit further. We're just going to look at the irrational and imaginary roots and how that's going to help us. So part A, we want to write these roots below separately. Andrew.
Yeah.
I want to write these separately.
3 plus, or actually,
Thank you. X equals 3 plus. You could. Okay. Radical 5 over 2. Okay. Got it. All right. So there's the two roots written separately. Describe the roots, Ella.
Imaginary.
And there's two of them, right? And what vocab word could you use to describe how they are related to each other? Conjugates. All right, so reminder, we'd already talked about this. Imaginary roots always come in pairs, correct? Conjugate pairs. Okay, they always come in pairs. All right, how about this one? We'll write it separately. Done. Careful. Good.
And then x equals -5 minus 5 plus 1 minus 2.
All right. Describe the roots here. Eric? Two of them. And what do we know about these as well? Conjugates of each other. All right, so got the vocab down. So irrationals and imaginaries always come in pairs, and they're conjugate pairs. Okay, let's apply here. If one root of the quadratic equation is 3 plus I, so root 1 is 3 plus I, then what do I know about root 2? 3 minus I, right? Conjugates. Write a quadratic equation having these roots. So there are an infinite number of equations that could have this roots, but we're looking for just one, right? Okay. And you know how yesterday, I can't remember what the name is, we decided like when and in the past, when we've had things like nice ones like x equals 3 is one root, and we determined x equals 2 is another root. And we worked backwards, like, okay, well, that would be x minus 3, and that would be x minus 2, and it would equal 0, and then I double distribute, and then I'm done, and I got an equation. So it's nice and easy, right? However, you could do that with these. You don't want to do that with these, but you could. So I could say x equals 3 plus I, and x equals 3 minus I. Then I'd have to subtract and say x minus 3 plus I, parentheses around that, and x minus 3 minus I, parentheses around that, equals 0, and then I have to start with those three terms, and that would get a little messy, correct? Okay, so what's better for us is to use what we did yesterday, right? We don't have to do things out backwards. We can use the information that we got yesterday because we know that the sum of the roots and the product of the roots is just as nice to help us write equations, right? Gives us the information we need. So sum of the roots, what would I be doing? Adding those together, right? And they're conjugates, so 3 plus I plus 3 minus I. Well, what's my sum? 6. I mean, you can't get much easier than that. And the product of the roots, so I got 3 plus I. That's a little bit more work, but really honestly not a ton. Right, gotta double distribute. So that's gonna give you 9 minus 3I plus 3I, that cancels, minus I squared. What do I know about I squared? -1. So 9 minus -1 or 10 is my product. Alright? So since I'm allowed to just write any quadratic equation I want as long as these are the roots, right? Then based off this, I'm gonna make a 1. Right? Because the denominators are 1, so that's good, that's easy. Okay? So I know that sum of the roots is equal to what? -b over a. And I got a sum of 6, so 6 over 1 is equal to -b over a. So we said yesterday that we know then when a equals 1 that b is going to be what? -6. I also know that the product of the roots is equal to what? C over a. And I got 10 as my product. So that means when a equals 1, c is going to have to be 10. So I've got all the info I need. A is 1 in both cases. So I go to write my equation. 0 equals x squared minus 6x plus 10. Or I don't care, you can call it y equals x squared minus 6x plus 10. The only reason they do 0 is because there's an infinite number of equations where that could hold. Yep.
When would it be that the x squared has a number in front?
I mean, I could have done that. I would have just had to adjusted these. If I wanted a to be 2, I could put a 2 over it and make that a 12. 12 over 2 is still 6.
Oh, okay.
You see what I'm saying? It's not,
Yeah. Okay.
okay? That's still going to make it have the same root. Yeah. No. Can you get out your graphing calculator? And type in the equation that we say is our answer. We say y equals x squared minus 6x plus 10 is the answer that we want. And if you went to look at the graph, even though you couldn't guarantee you were right, what would you be looking for to at least feel better about it? So how would I know by looking at the graph that it's all the way above, or in our case above because it's positive, right? So in other words, that it's not going to be crossing the x-axis, right? If you type in an equation, you look at the graph and it's hitting the x-axis, you know you've done something wrong, correct? Okay, that can't be the case because they're imaginary roots, which means it should not have any x-intercepts. So are we okay in that piece? All right, how could you guarantee that these answers are right since you can't find them in your graphing calculator like you can if they're x-intercepts? What could you do in your calculator that would allow you to check your answer so you knew before you left that you were right? Yeah? No? Yeah?
You could input the roots as you could store them. And
Store it. Okay, go to your calculators. Let's practice. So we're storing what? We're storing 3 plus I, right? So 3 plus, I don't know what the I is, second decimal, STO key as x. Enter. What was my equation? X squared. Minus 6x I have? Minus 6x plus 10? Yeah. And what should my answer be if I'm right? 0. Boom. And I could certainly check the other one, but we know they come in pairs, correct? So if that one works, the other one has to work. Good there? Questions? Alright, so you should know on your test, right? Right or wrong before you even leave. If you're wrong, you just gotta try to find a mistake. Okay? Try another one. Now we're looking at irrational roots, right? So if the first root, root 1 is 5 plus radical 7, what do I know, everybody, is the second root? 5 minus radical 7, but they are conjugates of each other. And I want to write a quadratic equation that would have these as roots. Okay, what do I know about my equation when I'm done writing it? If I went and looked at the graph, what do I know? It should hit the x-axis in 2 spots, correct? Okay? The estimate of these values, yep.
Is it just wondering if radical actually using the
Yep. For either they're imaginary or they're irrational. Okay? Good. Alright, so now what are we gonna do? Find the sum, which again is not bad here. So my sum is what? 10. Find the product. So 25 minus 5 radical 7 plus 5 radical 7 minus what? 7. Cancels out. 25 minus 7, 18. Again, out of convenience, we're going to leave A as 1, right? Both of those are going to be over 1. You don't think it might be? Oh. How did I look at this? Okay. So now we have our sum, which is 10 over 1, and what should that equal? Negative b over a. So when a equals 1, b has got to be what? Negative 10. And I know my product is 18 over 1, so that's equal what? b over a. So when a equals 1, b equals 18. Which means one possible equation is 0 equals x squared minus 10x plus 18, or y equals x squared minus 10x plus 18. So good? Questions? Yep.
They were different in Oregon. You multiply to get a common denominator.
Yes, you want them to be the
So
same.
you would multiply both?
Yeah, you gotta make sure, if you change A to 1, I'm saying when A is 1, that's what this is. But if A is 2, then this has gotta be negative 20. If A is 3, this has to be, right?
Yes, yes.
Yep.
Can you also specify
Well, this one wouldn't be factorable to get these roots, but quadratic formula you would have to do again. You mean, that would be, like, do the quadratic formula on it? I wouldn't want to do that, I'd rather just store it. Right, you can still store this too. Are you guys okay with storing this also? Got it?
use those methods to make an equation with like arbitrarily large ABC values? As long as,
As long as you multiply through, if all you have is the roots, and you have no other information, there's an infinite number of parabolas that could work. Big numbers, small numbers, whatever.
So you can use this to get any parabola that you want.
I would, yeah. Assuming it would go through those, you know what, but I mean, if you have more information, then you want the exact parabola, that's different.
Yeah.
Right, but if all the information you have is roots, then again, there's an infinite number, so basically, find a basic one, multiply through by whatever you want, and you've got a parabola that goes through those roots. Okay? Yep,
If you have to find like the specific parabola, I forgot.
yeah,
Are you gonna like Newland?
Yeah, we're getting okay, questions? Alright, if the roots of the equation are the following, what is the value of C? Okay, so what do I need to do here? Product, do I have to find the sum also? No. Okay, so we're finding the product. And they were nice, they gave both to you, but they really would not have had to, correct? They could have just given you one, and we still could have done it. So double distribute, I got 4 minus 6i plus 6i minus 9i squared, cancel, I squared is what again? -1, so this really becomes plus 9 or 13. If you're confused, I can write it out. We've got product 13 over 1 equals C over A. A is 1, that matches up in my equation, so there's no issue there, which means C has to be 13 in the front. Questions? So if A up here was 2, you could just fill in 2 here across multiplying times C, right, if you wanted to. Alright, if the roots of the equation are the following, what is the value of k? What do I need to do? Sum, right? 4 plus radical 10 plus 4 minus radical 10 tells me my sum is 8. And so if my sum is 8, that's equal to negative b over a. A is 1 up here, so I don't have any issues there, right? And so I know b is going to be what? -8, which in this case is k. Right?
So if it says like, what is the value of k, and you have something like b equals -8, that would be wrong.
I mean, technically you're not answering the question. I can't guess as to what you think k is. You know what I mean?
Yeah.
Other questions? Alright, so same idea, but you're looking at a graph now, right? Okay, and you want to figure out what k is. I'll give you a minute. Oh, go do that. You want to share their answer and tell me how to do it? Alma?
I got 4.
4. And Luke did.
I found the sum of -2 minus radical 7 plus -2 plus radical 7,
Yeah.
and then you would get -4, and then you do that negative b over a equals -4 over 1, which would give you a equaling 1 and b equaling 4.
And since a is 1 in your equation,
Yeah.
right? So k is equal to 4. Final answer. Questions there?
Yeah, when you know it's like negative, like when you do the sum and you know it's -4, can't you just change it to like?
You can. Fairly unoccupied issues
Oh,
with
yeah,
it,
yeah.
just saying. Alright, okay, so that's my equation. What do you know about the value of the discriminant based off the graph? What do I know about the value of the discriminant? Be careful with your vocab here, that you use discriminant vocab. Oh, positive. And what else? Can't say real, because that goes with roots, right? So, is it a perfect square?
No.
No, because these are what type of roots? Irrational roots. So that means that the value that you would put under the radical in the quadratic formula has to be a what? Non-perfect square, right? And the only reason I'm allowed to say it's not a perfect square is because they gave me the actual roots, right? If they just crossed twice, I wouldn't know whether it was perfect square or not a perfect square. Is everybody clear on that? Okay, it's gonna cross twice if they're real, or once, or touch once, right? Okay? But they could be irrational or rational. What is the value of the discriminant? Yeah? 8, I'm gonna say that. Is it 7? Actually not 7. What is it? Let's figure it out, right? How would you find it? You would go b squared minus 4ac, correct? Okay, so b squared would be 16, right? Minus 4 times 1 times negative 3, correct? And so that would be 28. Now why? I know why Lucas said 7. Do you guys know why he said 7? Because 7's underneath the radical. So why isn't that the discriminant? Isn't that what we do? We put the discriminant underneath the radical? Because it's simplified, right? Because your quadratic formula is really over 2a, and that's already been canceled out. Okay, so you guys gotta be in, obviously they simplified that radical. You guys good there? Okay. And last piece, just to make sure, type this equation in that we think is our correct answer. Go to your graphing calculator, go under y equals, type it in. You've got an exact parabola here, so you should be, all your solutions are sitting right in front of you, correct? So where are all your solutions on your calculator? You don't know where all the solutions are in our calculator?
Second graph.
Which is table, right? In the table, right? So type this into under y equals, go to your table, and tell me what it says at 1. What does it say the solution is at 1? 2, oh that looks good. What about a 0? Negative 3, that looks good. At negative 1? Negative 6 is good. At negative 2? Negative 7, and negative 3, negative 6. So is that the right equation? Yeah. Because we are getting the correct solutions, right? Questions on that? Still good. All right, let's try this one. I'll give you guys a minute because I like this one. This is a nice one. See how you can do on your adding sums and products here. See how good you are with your fractions. Try to do without plugging everything in your calculator. Give it a shot, then you can check yourself in your calculator. You can check your final answers, I believe, after you're done editing.
When I'm adding it,
Yep.
I'm getting
Not something nice?
3. No, I'm getting something nice, but like theirs is negative 3. I'm getting 3.
All right, so let's see. So your sum should be negative 3 plus radical 11 over negative 2 plus negative 3 minus radical 11 over negative 2. What do you need in order to add fractions? Common denominator. Do I have one?
Yeah.
Okay. So then I could really write this as negative 3 plus radical 11 minus 3 minus radical 11 all over negative 2. Right? That's what a common denominator does for you. And then plus radical 11 and minus radical 11 cancel out. So really it's just negative 3 and negative 3, which is negative 6 over negative 2, or 3. So your sum is 3. Yep.
Just like for the product isn't it over two, so she can just leave it under two?
Well, let's think for a second. When you're multiplying for the product, let's say we're multiplying 2/3 times 1/7. How do you multiply fractions? You multiply straight across, so it'd be 2 over 21, right? So that's not gonna change. Well, we can reduce at the end, but that's not gonna change. Your rule is still the same, right? So that's not gonna be that bad. So if we go product, then is equal to -3 plus radical 11 over -2 times -3 minus radical 11 over -2. So if I multiply the bottom, that's easy. What do I get on the bottom? +4. So I got +4 on the bottom. And when I multiply the top, I'm really just doing this, right? -3 plus radical 11 times -3 minus radical 11, which we've now done a lot of times. So -3 and -3 is 9. +3 radical 11 minus 3 radical 11 minus 11. Cancel, cancel. 9 minus 11 is just leaving me with -2 on top, which is really just -1/2 for my product. We're okay there? Okay. So then I know my sum is 3 over 1, which would equal what? -b over a. So when a equals 1, b is going to equal what? -3. And I know my product is -1 over 2, and that equals c over a. So when a equals 2, c is going to equal -1. What's my issue? A's don't match up. So what would be an easy fix on that to get an equation? Multiply the sum values by 2, right? So if I want this to become 2, I gotta multiply them both by 2. So that means when a equals 2, I know b would equal -6. You guys okay with that? Okay, so then my equation should be y equals 2x squared minus 6x minus 1. Good to go? Oh, darn it. We were so close. What's the issue? This parabola is upside down. Can that be the equation for this parabola? It is not possible. And so what did we say? When you start with the roots and you find an equation, you are just finding a possible equation for those roots only, which clearly that is not the right equation, okay, for this particular graph because I have more information. Okay, so I can't just pick whichever one I want. It's got to match up with that data, correct? Or those solutions. All right, so go back and think about what we had done in the past, right? We know we could literally multiply through by any number. I could multiply through by 100 if I multiply through every single one, and I'm still going to get those as roots, right? I could multiply through by -10 and still get those as roots. So what do I need to do? We call that the a value that we would multiply through by. How do I figure out what that number is that I want to multiply by? You pick a solution. Don't I have a whole bunch of solutions sitting right here in front of the graph on me? So pick one. What do you want to be, what solution you want to use? 0, 1 would be nice. Yeah, I agree. So this is not the right equation, but we can use it to help us, right? So we know it's got to be some version of that. So we want to use solution 0, 1. Okay, so then y has to be 1. I'm trying to find that a value that I'm going to multiply through by, right? That's going to fix this for me. Okay, so it's going to be 2 times 0 squared minus 6 times 0 minus 1. Right, just plugged in my solution. So everything's filled in except for a. So now it should tell me what that a has to be to make that be a solution, right? So adjust the equation. So then what do I got here? I really have 1 equals -1a. I do my PEMDAS and do what's in the parentheses. 0 times a, 0, 0 minus 1. So a has to be what? -1. So what do I need to do to this equation? I'll make this a zero. What do I have to do to fix it? Multiply the entire equation by -1, right? So my final equation for this graph then should be y equals -2x² plus 6x plus 1. Go to your graphing calculator, type it in under y equals, go to your table, and make sure that my things are matching up. You got a better way?
Well, yeah.
Okay, so what do you like?
So I did it first where it was like, I kept it as 6/2, the sum. The sum, I kept it 6/2.
Okay,
And then I saw.
which is what we got to it. You mean
Yeah.
-6?
Yeah, that's it.
Okay.
Wait,
Well, b is -6 for -2, so what you mean?
no, I'm just talking about like not when, not be anything, like not.
Oh, not
be-
finding b, I
So
got
I
you,
just
I got
kept
you.
the sum as
Mhm.
6/2.
Yep,
And then the product is -1.
okay,
And then I figured that you needed a common denominator anyway to make it.
so you have one.
So I made it -2, so I just negated the sum.
Okay,
And then I got the same equation.
you did, but you still have to be careful there,
Okay.
because there's not, it was a 2,
Yeah.
but it could have been another value, do you know what I'm saying?
Yeah, yeah.
So you would still have to double check it. The thing is though, if you look at the graph on this, okay, this is sitting at +1, or, this is at +1, and, your y-intercept is at +1, and in our original equation, it was at -1.
But I never had that equation.
Right, but so I'm saying another possibility was, since I was at -1 and this is at +1, you can kind of see that it's reflected through the x-axis. Just something to think about. I thought that maybe that's where you're going. Yep.
So like, could you just, instead of doing like all of that,
What
could
do
you
you
just figure
want?
out like what number you need to multiply your C value by to get to the C value on the graph? Or like,
I mean,
Like-
technically, as long as you multiply through by that whole thing, I guess, yeah.
yeah,
Similar idea there.
okay.
Because you've got to multiply through by some value to every
Yeah.
value,
And
right?
then like, if there's like a y-intercept, all the x's would just be 0 anyway.
If you have a y-intercept, your
Yeah.
x's will be 0, correct.
So that would work for any graph. whether
That's
it's
kind of what I was
y
saying here with the reflection idea. Are we okay with that? Okay, so what do we know about the discriminant based on the graph? Gotta be positive, and not a perfect square, because these are irrational. And the actual value of the discriminant, let's find it, b squared 4ac. Someone checked our equation, right, it was good? What I got, 36 minus 4 times -2 times 1. 844? Yes? So 44 is our discriminant value. Am I okay with that? That would be 36 plus 8. Questions? All right, you guys got the last one. get an 8 for our K value. Because our A value is 1, so we didn't have to do anything with that. And then, what do you know about the discriminant? That is not the vocab word for discriminant. Negative. Be careful with that. Okay, you are describing the roots, not the discriminant. So the discriminant is negative. Questions? All right, homework is at the bottom. I think it's in your packet, right?